Hi everyone, welcome to our second tutorial. In this tutorial, we are going to look at how to create a sprite using Pygame. We're also going to have a look at object-oriented coding in the context of game programming. So, at the end of last lesson, we had our code to the point where we are able to go to a menu, click the play button, and go into our actual game. And just to revise what we did, we had a game loop. Inside that game loop, we processed input. We then did some drawing, and we created two areas inside our game loop. We actually created one area where if the game state is equal to start game, and the second area where our game state is actually running. So you can see that the start game was our menu, and the game state running is where we are going to actually have our game. So there are the two parts of our program at current. We're now going to put in our players object, and this is a good intro to object-oriented coding, as in Pygame has an object that it uses for things appearing on your screen, and it's known as a sprite. So you should have, my students anyway, will have done a bit of object-oriented coding as a precursor to this lesson. By the way, if you're behind from last lesson, you can always go to my GitHub, go to the Pygame template, and if you go to lesson 2, you'll be up to date. So you can always download lesson 2 if you're behind. All right, so if we actually have a look at what a sprite is, I've just done an example using diagram software. This is known as object-oriented programming. So in object-oriented programming, code is wrapped up in what we call an object. And it just so happens that Pygame has this object called sprite, and inside the sprite there's a couple of functions. There's a draw function and there's an update function, and the sprite has a rectangle, and then there's a whole lot of other code that we can't actually see. Our aim this lesson is to create our own sprite for a spaceship, and the spaceship is going to inherit all the code inside the sprite and then add some of its own. And hopefully, as we're doing it, you'll get a bit of a sense about how an object works. So you can see our game state is start game. We are going to, at the end of it, just where we've created, the user has just clicked the actual button, we're going to create ourselves an object called spaceship. So game.player is equal to spaceship, and I'm going to give it an X and Y position. Now we haven't created the spaceship yet, which is why I've got the underline there, but we are going to. I don't think there's anything else there at the moment. Oh yes, there is. We also play the music. So at the end of last lesson, you should have this code. The one line of code you're missing is game.player is equal to spaceship. And what we're going to also do is we're going to create a file called spaceship.py, and that should be inside your main folder. And then inside our main file, we're going to import in that file. So we're going to use the line from spaceship, import spaceship. And you're going to add that to the top of your main.py file. And what that's going to do is it's going to look inside our spaceship.py file for a variable called spaceship. Okay, so this is our spaceship.py file. Now we're going to import Pygame into the code. We are also going to, don't have to worry about lasers yet, we're also going to import our globals. And if you remember from our previous lesson, the globals file is going to contain variables that we want to access from multiple files in our game. So by putting our globals inside game globals, we change the name, give it an alias to game. We can actually access the same settings as what we did inside main. And then finally, we're just going to import in math and time, because math and time are useful to us. Now, to create an object we use what's called a class. A class is a blueprint for the actual object itself. And you can see that we've created this class called spaceship, but I'm going to base this class off another class that already exists, which is the Pygame Sprite class. And by all means, I would Google this or use Ask ChatGPT to explain it to you. In fact, there is a highlight here. It explains what a sprite does. It says it's the base class for a visible game object. Derived classes will wish to override the update method and assign an image in a rectangle. So this object, this sprite object, is used for anything that's a visible object inside our game. And when we construct the object, we actually call its init function. So you can see I've got this thing called def, define the function, underscore underscore init underscore underscore, and then I give it an X and Y position. The thing about using objects is that we always have to provide the word self. It's kind of a weird one. I know there's been discussion about whether the word self is even required, but it's what you do in Python. So we've created a class and we've given it an init function, and then we're actually going to call the init function of the class that is inherited from. So going back to our diagram, our spaceship class, in fact I should probably call this class spaceship, is actually inheriting from the class called Sprite. And that basically means all the code that's in there comes into our spaceship object. Next, we're going to give our object an image. And what we do is we use the precursor of self to basically describe any variable inside this object. So the thing about an object is the object contains its own variables and contains its own functions. So we're going to load an image inside this variable called self.image. So the image is an image variable inside the object. This probably isn't important yet, but it will be later on. We can actually scale that image. So the image I'm actually loading is inside my images folder. Again, I got this online. You can always replace the image with your own, and I'd encourage you to do so. But you'll want to scale it. Ideally, try to scale the image outside of the actual VS Code itself. But if you ever did want to scale the image, this is the code that you would use. The other code that we're going to put in is we are going to put in the original image, which is a copy of it. Now, the only reason you need this line at the moment is so that you can use rotation at a later stage. And I'll explain why when we get to that, which is a few tutorials time. In terms of sprite movement, we're going to give it a few variables. We're going to give it a direction. We're going to give it a speed, and we're going to give it a speed limit. So the direction is which way is the sprite facing. Again, not necessary yet, but will be necessary later on. The speed is how fast can the sprite move. And the speed limit is if you keep increasing the speed, the sprite would move faster and faster over time. So is there a speed limit? We'll just put in a speed limit of 3, which again will become useful at a later stage. And the speed, if you wish to know, is actually just the number of pixels per second. Then we're going to position our sprite. Now, we passed in an X and Y value for the position of our sprite. So to position the sprite, we need to position its rectangle. And the thing about Pygame is that it always uses rectangles. So we're going to position our rectangle. Firstly, we need to get the size of the rectangle, and we do that from using the image. So the image you can get the rectangle from. Remembering a rectangle consists of its X and Y position and its width and height. So self.rect will get its own rectangle. Then we set the position of the sprite to equal Pygame the X and Y position. I'll explain the use of vectors at a later stage, but just know that the position is an X and Y value. And then finally, we have to set the center of our rectangle to that X and Y position. And that's what that line does there. Eventually we're going to have a shoot time, but we'll just leave it as 0. And then we return, and that is our init function. So what that means is that our class, when we create this spaceship object, its X and Y will get passed in, it creates an image, gives it direction and speed, and then sets the position of its image, and that's as soon as the object is created. Next, we're going to create a draw function. The draw function will be called every frame, and you'll see how we do that in a second. But when the draw function of the object is called, we are going to blit the image at its rectangle. So if the sprite has a rectangle, we're going to blit the image at the position of that rectangle. And then we're going to return. And then last of all, we're going to give it an update function. And I'm just going to go pass here for the moment. The update function will be called every frame, and the draw function will be called every frame. So I'm just going to minimize the init method for a second. What we've got is in our class, the class is a blueprint for an object. When we create the object, we initialize it. And then these two functions here, draw and update, are going to get called every frame by our game loop. So our game loop is going to keep wanting to update the sprite's position, and then it's going to want to draw the sprite on the screen at that position. So update, draw, update, draw, update, draw. You can imagine how every object that we put in our game will have that same kind of format. Okay, so that's done. We're ready to use that object now. I'll just expand that so you can see all the code so far. And now, if we go back to our main, you can see I've imported in from spaceship import spaceship, which is actually that piece of code. So I'm going to import in that specific piece of code. And then if I go to my game loop, I'm going to want to, inside the running part of my game, remember we created the object here inside start game. The reason it's there is because once you start the game, it's only going to create that object once before moving on to this part of code. So one of the things we do want to do is make sure that we can't have game.player inside our running part of the game. Otherwise, it would just keep creating a spaceship every frame. So instead, we create the spaceship there. We've stored that globally inside the globals. Game.globals has stored that. And then inside here, we're simply going to have if game state is running, if game.player, I am going to simply go player.update. And the other one I'm going to do, and I realize I should probably have it up here. Oh no, actually, I'll have it in two sections. If game.player, I'm going to go player.draw. So I've got this in two different sections at the moment, and you're probably thinking, well, why? Why would I not just go game.player.update and game.player.draw? The reason is because eventually I'm going to have more sprites that I wish to update, and eventually I'm going to have more sprites that I wish to draw, and I actually want to put them in different areas of my code. So I've just put that there for the moment. But the important thing is that if it is going to update my player, the player must exist. And if it's going to draw my player, the player must exist. So I'm actually testing to see if the object exists before I update and I draw. But you can imagine that that code there is going to get run every frame. So every frame it's going to update my player, and every frame it's going to draw my player. And if the player is moving, well then the update function of the player will change its position, and then it'll draw it somewhere else on the screen. Okay, so I'm going to stop the tutorial there. Let's just see if it's running at the moment. Hopefully it is. And hopefully we should see our player on the screen, which we do. So we can see the player is there, but it's not responding to input. As an extension for this, what I'd suggest you do is see if you can actually create another player. So what I would suggest you do at the end of this tutorial is see if you can create another player object and see if you can also have that being drawn on the screen. Okay, thank you very much. I'll see you in the next tutorial.